Hi scientists, this is your video for Module 10, and if you're watching this because you couldn't get into the Zoom, well, I fixed the button so it should be working fine. Whenever you click this, you should be able to log into the Zoom. Sorry about that. So let's try and make this as efficient as possible so that you can catch up. First off, if you didn't already, try the warm-up. See what you get out of 7 points. Okay, once you've tried the warm-up, we're going to go to our notes on heat transfer. So this is a new set of notes. You got to click the link and open a copy, make a copy, and once it finally loads, you're going to move it into your Unit 4 I've Got the Power folder. So today we're going to learn about how does thermal energy move from one place to another. So we're focusing on one of our many forms of energy, thermal energy, which of course means heat. So we're going to talk about how do you get warm when you're cold? How do things that are not warm heat up, such as food? Okay, now that I have this all loaded, use this button up here to move it into the correct folder so that it's with the other notes from this unit. So find your science folder and put it in Unit 4, I've Got the Power. Perfect. So they're pretty short, fill in the blank. We are just going to learn about these 3 different ways that thermal energy moves around. It's called convection, conduction, and radiation. All right, so I'm just going to take you through this. There is Pear Deck involved, but we'll just talk about it. So when you're cold, what do you do? When you're cold, what do you do? Let's say you just came in from outside. You might get a blanket. You might run your hands under some hot water. You might go sit by the vent. So there's lots of different ways that your body can warm up if it's too cold. When your house is cold, what do you do? So your house is cold. You need some thermal energy in your house. What do you do? Maybe you crank up the thermostat to blow some hot air in the house. Maybe you light your fireplace. Maybe you turn on a space heater and just heat up the air around you. All right, so right now it's in the middle of winter. It's February 2nd. Why is it cold outside right now? So obviously because it's winter, but why does winter happen? Well, if you're looking at this diagram and thinking because the Earth's axis is tilted, you're right. So when the Earth's axis is tilted and we in the northern hemisphere are facing away from the sun, so that'd be like this. So more of this half of the Earth is dark than light. Okay, this side is more light than dark. This side is more dark than light. So when we're tilted away like this, then that means it's winter here. And that would mean it's summer on the other half of the world, which is the southern hemisphere. Okay, so it's summer right now in Australia. It's summer right now in Argentina, but it's winter in the northern hemisphere. And the reason that it's winter in the northern hemisphere is because when we're tilted away, we get less sunlight, and less sunlight equals less heat. We also get less of a direct hit from the sun. So the sun's rays aren't shining on us as directly. Over here, they're more direct, hitting straight on. Over here, they're less direct. So it's less energy transferred to us. So being cold means not having enough thermal energy. So today we're going to talk about the 3 ways that thermal energy travels around our world. Again, convection, conduction, and radiation. 3 methods of transferring thermal energy. So let's start with convection. Convection happens in fluids. Fluids are gases and liquids. So usually we're talking about air or water. So in fluids, warmer matter rises and cooler matter sinks. This is because the changes in the density of the matter. So warmer matter is less dense, and if it's less dense, it floats. Colder matter is more dense, and if it's more dense, it sinks. Let's look at some examples. So convection is all over the world, including inside of it. Convection, we first learned about it when we talked about the layers of the Earth. In the mantle, there are convection currents moving the super hot rock, and that in turn pulls and pushes the tectonic plates up here and causes things like earthquakes and volcanoes and mountains. Another example is wind. So wind actually blows because of cold, dense air sinking and warm, light air rising. And that's what causes a breeze. So when you feel a breeze outside, you're feeling convection. Ocean currents. Ocean currents are super important for ocean life, for ships, for weather even. Those are caused by hot and cold water flowing in the ocean. All right, on a more personal note, convection is also what keeps your house warm. You turn on the air or the heat and the heat and air starts flowing. That's convection. It's also it's what cooks your pasta because it's in water. So whenever you boil something to cook it, it's using convection to spread the heat inside of the pot. So I did not mean to do that. Okay. All right, so this would be the pear deck, and you're not in the pear deck, but in class we did a little demonstration. We put some red food dye down here at the bottom, and we watched it rise up from the heat on a hot plate. And the red rose up. I also put some blue food dye at the top of the water, and we watched it sink down because it was colder. Once it got to the bottom, it all mixed up, and now I have some purple water. I know it kind of looks black, but it's purple. Trust me. So that purple mixture was formed by convection, spreading the thermal energy and also the food dye. Okay, our next one is called conduction. So conduction is when heat is transferred from one molecule to another through direct contact, so touching. This can happen with all three states of matter, but we often talk about it with solids first. So let's say we're sticking a metal rod of some sort over a flame, we're heating up this end. Well, eventually, given enough time, the heat will travel all the way to the end and your hand might feel it. So what's happening is each of these rows of molecules is getting the heat from the row next to it until the whole thing is hot. Some examples of conduction. So conduction, think of two things touching. Direct contact. A good way to remember it is conduction has a D in it. Direct contact is D for direct. Conduction is what burns your feet on the hot sand and cooks your eggs in a pan. Conduction is what gets wrinkles out when you iron. So we're putting the iron directly on the clothes. That is conduction. It's also what straightens or curls your hair if you're using an iron. All right, which of these do you think are good conductors? So conductors are something that heat travels through easily. So if you grab the end of one of these and stuck the other end in fire, which of them would eventually burn your hand? So the best conductors are metals. So copper and iron, they allow the heat to travel up them without burning or melting. So wood, would catch on fire. The heat itself wouldn't travel up the wood, but the fire would, and that's what would burn you. Plastic, it would probably melt first before it let the heat travel up to your hand if you were holding a metal pipe into a fire. But iron and copper, they won't melt, they won't burn, but they will let the heat travel up through them, and eventually you'll feel it in your hand if you're holding the other end. All right, last one. So heat can be transferred through empty space in the form of radiant energy. It's what we call radiation. Radiation is the process of giving off thermal energy in all directions. So anything warm has thermal energy. You can feel your own thermal energy if you hold your hand up close to your face. All right, some examples. Radiation is what warms your burger in the microwave. It's what warms your hands near a fire. And it's what warms your cat in a sunny window, that sunny spot your cat loves. The heat's coming from all the way from the sun, millions of miles away. So, radiation demo, well, this flame gives off heat in all directions. So in the Pear Deck, we drew heat coming off of it in all directions. That is the effect of radiation. How come the wax of the candle melts from the flame? Doesn't it look like the flame is going up? Well, radiation goes all directions, even down. Okay, here's a video which you should be able to watch. So I'm not going to play it right now, but you should watch it. It's about warming up chicken nuggets. How do you warm up chicken nuggets? Watch this video, it'll help you. And finally, you can go try out the practice activity. So this is just an exit ticket to show how much you just learned. Use your notes, you just learned it, use your notes. So you're gonna match the definitions, you're gonna match some examples, and you're gonna match 3 examples in 1 picture. Good luck.